Welcome to today's video. In this video, I'm going to continue looking at the topic of approximation and estimation. In today's video, I'm going to look at a wonderful topic entitled scientific notation. In this video, I'm going to look at scientific notation. So I'm going to describe what scientific notation is, and I'm also going to show you how you can write numbers in scientific notation. So watch this video up to the end, as I'm going to describe and also show you how you can write numbers in scientific notation. Okay, let me start with describing what scientific notation is. So scientific notation is a special way of writing very large and very small numbers. So scientific notation is a special way in which you write big and very small numbers. So very big numbers as well as very small numbers can be easily written in scientific notation. So if someone asks you to write numbers in scientific notation as well as in standard form, that means the person is asking you to do the same thing. What I'm trying to say is the other name for scientific notation is standard form. So if you are told to write numbers in standard form, or you maybe at the same time, maybe or at a different occasion, they ask you to write numbers in scientific notation, they're asking you to write the same thing. So if you're told to write 3000 in scientific notation and the other person is asked to write 3000 in standard form, they have just asked you the same thing using different weights. So the other name for scientific notation is standard form. So these are the things you need to get note of. Scientific notation is a special way of writing very big numbers and very small numbers. The other name for scientific notation is standard form. Okay? Now let's look at parts of scientific notation. Okay? Scientific notation is made of two parts. The first part is a decimal number between 1 and 10 but not equal to 10. Okay, so the first number you write should be decimal numbers between 1 to 10. Okay, so these numbers, they shouldn't be equal to 10. Okay, that is the first part of the scientific notation. The second part is where I multiply by 10, the next part is multiplied by 10 raised to the power. Okay, so these are the two parts. There is one part which is made of the decimal numbers which are less than 10, and the other part is multiplication of 10 raised to the power, multiplication multiplied by 10 raised to the power of the given number. Okay, you are going to understand this more when I start solving or when I start writing numbers in scientific notation. Okay, so since I want you to understand well, let me go into writing numbers into scientific notation, Okay. So here are the numbers, and the instruction is write the following numbers in scientific notation. So what we're going to do is we're going to write first the decimal number, which is between 1 and 10, but it shouldn't be equal to 10. It should be less than 10. So you can write 9.9, 9.93 like that, but it shouldn't be just be equal to 10. Okay, so we have this question, which is number 1, which is this number which has 8 zeros. That is, how much is that? That is 300 million. So we have got 300 million there on number 1. Now we are supposed to write 300 million in scientific notation. So what we're going to do is we're going to write 3. We're going to write 3. Even if we write 3.0, it will have the value of 3. So we're going to write 3. Then we're going to multiply it by 10. Then now to raise this 10 to the power, we're going to count the zeros. Okay, so we have got 8 zeros there. That means we're going to raise 10 to the power 8. Okay, so now writing 300 million in scientific notation will be 3 multiplied by 10 raised to the power 8. Okay, now let's go to question number 2. Okay, so in question number 2, what we're going to do, we're going to count zeros from the decimal point. We are going to ignore this 0 I've circled in green. We will ignore it, then we'll count those zeros starting from decimal point going to the right up to 5. 5 also will count it. So when you count that, you also count 5. That means we're going to write 5.16. The decimal point has come between 5 and 1. Now it has become 5.16. Now when you count those digits the decimal point has passed, you find that they are 7. Now since they are 7 and the decimal point is moving from left going to the right, that means the power will be a negative. So it will be negative. So when you multiply 5.16 multiplied by 10, then you will raise it to negative 7. Okay? Why? Because the decimal point is going to the right, not going to the left. In other words, it's like the decimal point is losing it's more or less like losing value, or yeah, something like that. Okay, so we are getting a decimal point from the left going to the right, so the power will be a negative. The power has been a positive. It is a positive on number 1. The power on number 1 is positive because the decimal point is going to the left, so it has become a positive. So when it's going to the right, it becomes a negative. When it's going to the left, it becomes a positive. Okay, now let's go to number 3. So before I go to number 3, let me show you the numbers I counted for me to get 7. Those are the digits I counted. So starting from the 0 from the decimal point, that is 1, then 2, 3, 4, 5, 6. There are 6 zeros plus 5, that is 7. Because the point will come between 5 and 1. So it will be raised to the power, which is negative 7. Now that's the same thing we're going to do here. We are going to count numbers from 3 up to the last 0 going to the right. We are going to start from the left going to the decimal point is coming from the left, from the right going to the left, and the decimal point will be between 2 and 3. So that's what we're going to count those digits. The decimal point has jumped to reach up to the space which is between 2 and 3. So we are going to write 2.34 multiplied by 10. Then we're going to count the digits the decimal point has crossed. So when we count from the last 0, we start from the last 0. We start from the last 0, that is 1, 2, 3, 4, then 5, 6. So it has crossed 6 digits for it to reach the space between 2 and 3. That means we are going to raise that to the power 6. Okay, we are going to raise 10 to the power 6. So writing 2,340,000 in scientific notation will be 2.34 multiplied by 10 raised to the power 6. Okay, let's go to question 4. Question 4, we have got 0.0013145. Then we are asked to write this number we write this number in scientific notation. So what we're going to do is we're going to identify the movements the decimal point will make. So the decimal point will move from that point up to the space between 1 and 3. That means the decimal point will jump 3 digits. Okay, so when it jumps 3 digits, we're going to have 1.3145. Then since it just jumped 3 digits, then we are going to multiply by, okay, then we are going to multiply it by, then the number of digits the decimal point has crossed, they are 3, so we're going to multiply by 10, then raise to the power -3. Why? Because the decimal point has crossed 3 digits. That's why we have raised it to the